Today, I'm delighted to have this opportunity to tell you about the technologies that we have for Microsoft Research that you can use in your daily work. So I don't know how many of you actually heard about Microsoft Research. This is a sort of a quick introduction to Microsoft Research. So Microsoft Research was founded 20 years ago. So this year is our 20th anniversary. And we have 3 mission statements. One is to expand the state-of-the-art in each area that we do research. So we have over 850 PhD computer science researchers. And we actually do a lot of different areas from like computer science, like compilers, operating systems, languages, computer vision, etc. And then the second mission is to actually rapidly transfer innovative technologies to Microsoft products. So throughout our 20 years history, we've actually transferred a lot of technology into Microsoft products. So more recent examples are, for example, the Xbox Connect, and also in Bing, we actually have a lot of technology in Bing as well. And then the third is actually we want to ensure that Microsoft products have a future. So a lot of people have asked me before on the purpose for having a basic research department within Microsoft. And they'll always answer that for a company in a high-tech industry, it's very important to have this reservoir of expertise and knowledge that the company can draw upon when we want to explore a new area. For example, we actually did search and information retrieval related work for over 15 to 20 years in Microsoft Research. So when we actually started working in the web search area, we actually had a lot more experts in the company already that sort of had knowledge in that domain. So for example, the former managing director for Microsoft Research Asia in Beijing, Dr. Harry Shum, he's now the corporate VP running Bing product development in Redmond. So that's one example where we actually have this reservoir of expertise and knowledge that we can draw upon to explore new areas. And so we were founded in 1991 in Redmond, Washington, and now we actually are spread over majorly like 6 major labs around the world. So you can see that we actually have labs around the world, and also we have like collaborations. For example, we have collaboration with a lot of universities in Asia and also in the US and also in Latin America. And the way we are organized is that we are sort of organized as a computer science research department in the sense that we have a very, very flat organizational model. The way you think about it is our founding Vice President, Dr. Rick Rashid, he used to be the computer science department's head at Carnegie Mellon University. So he organized the research function to be very, very similar to the way a computer science research department work in a top university. So it's very flat. We actually organize around like critical mass groups. So for example, you might have one group on speech recognition, and then a group on computer vision. And then the researchers are encouraged to really pursue research that they are passionate about. So for example, a computer science researcher might come up with a problem on how to do face recognition. And then that problem is actually a long-term research direction for that researcher. And we have a very open research environment, so we have a lot of engagement and collaboration with the universities. So we also publish in major conferences and journals. For example, in the SIGGRAPH that just happened early this month, we actually published more than 10% of the papers in the whole SIGGRAPH proceedings. So you can see that this is a great example where we actually engage with the research community. And in fact, in addition to engagements, we actually have over 15% of our budget that are actually given to universities. So actually, we actually fund a lot of research in the computer science department because we believe that for the whole industry in general and for Microsoft, it's actually very healthy and important to have a very strong computer science research community because that's where a lot of the advances will come from in the industry. And then we host hundreds of interns and visitors over the years. So today I'm going to talk about 3 different resources that are available for Microsoft Research. First, I'll talk about Connect SDK that was launched in June this year. And then I'll talk about Show. It's actually a package that we can use for data analysis. And then I'll talk about Infer.net for machine learning. So these are 3 examples. So a lot of these SDKs we make available online on our website. And if you go to Microsoft Research website, you can find that there are even more. But today I'll just focus on these 3. So Connect, the original project name was called Project Natal. So it's actually named after a Brazilian city, meaning relating to birth. So this really came from Alex Kidman, who's a general manager for incubation for Microsoft Xbox team. And he's from Brazil. So the idea is actually to come up with a new generation of home entertainment devices that allow a controller-free type of experience. So how many of you have played with Connect? Raise your hand. Okay, so if you have not, actually, it's actually available in the hub downstairs. So I encourage you to go and try it. I think it's actually a very novel type of user experience. So it's more than just a device. It's actually new sensors that require a lot of computation power behind it to actually extract the meaning from people's movement and also from people's speech. And so it's actually something that's very complicated to do in computer science because there's a lot of noise. I mean, you can imagine, I don't know, how many of you actually attended the party last night, the TechFest party? Okay, maybe half of you. So you can see that in one of the rooms, we actually had the Connect set up, and it was actually very dark. And there's a lot of background noise and things like that. And you have to be able to extract people's movement from that kind of environment. So that's where a lot of challenge comes. So I know that there are actually several Connect-related sessions in this Tech Ed conference. So today I'm going to give you sort of behind-the-scene look on Connect and sort of give you a sense of the research that went behind it. So it was sort of decades of research in computer vision. So computer vision has been going on for over 20 to 30 years. And then the history is that we have this reservoir of expertise and knowledge within Microsoft Research. And then in September 2008, so the product team, led by Alex Kidman, actually came to Microsoft Research and said, we want to build this product that allows you to do a controller-free, sort of like very natural interaction with the game console. But we are facing a sort of set of different challenges, so can you help us? And then we worked with them, and then we actually sort of announced the concept in E3 in June 2009. And then after that, we actually launched the product last year in November 2010. And you can see that it has become a very, very successful consumer product. So in fact, it actually won the Guinness World Record for the fastest selling computer electronic product of all time. So up to March, we sold over 10 million units. So what went behind the product development? So you have many, many problems. First of all, you have to find people in the scene. So you can imagine that there are many, many different lighting conditions, like many different setup people have in their living rooms. So how do you actually ignore the background and actually find the people and understand the movement of the people? And then so you have to understand where the different body parts are and also to tell apart two different people. So actually we have an analogy for this in the sense that if you are involved in playing a game and get very excited, the last thing you want is basically like your little brother come into the view and basically just distract the system and then basically to lose the context of the game. So we want to make sure that we can actually identify and separate different people when you're viewing the gesture of the people. You have to track their gestures. So for example, if you're playing Connect Adventure and you're running around, you actually be able to actually track people's gestures. And then you also want to recognize faces. So one thing that we did for Microsoft Research in Beijing is actually we help to integrate the face recognition technology plus other technologies we have in the labs so that different users can be separated. And we can also identify people so that if you have an Xbox profile for Xbox Live enrolled in your game, if you walk into the scene, you actually recognize you and sort of upload your own profile. You also recognize voices so that you can actually give commands to users as a remote control for your Xbox console. So for example, you can use it to play movies. So you can say like Xbox pause, and you actually pause the movie. And of course, you do all this, but you cannot actually utilize all the CPU power of Xbox console. I mean, because the majority of the CPU needs to be devoted to actually the game, the rendering the game, and the game action. So what we do is actually we have a lot of sort of machine learning algorithms behind this work. So for example, you have trillions of possible body configuration for the 32 body parts we track in Connect. And then you have to do it many frames a second. We do it on a frame-by-frame basis. And then you have to utilize less than 10% of the CPU. So these are all the challenges we face when we're trying to create this program. So there have been a lot of computer vision research spanning back many decades. So both in academia and also in research, in Microsoft Research, and also in the Xbox team. So back in 2007, if you look at the state of the art, it had the ability to track people in a video scene. And in fact, they're working in that area, for example, to track the number of people. For example, you can count the number of people walking inside the hallway, for example, and also identify their gestures. But it's limited in terms of like how fast it can sample, and it's usually not in real time. So in the requirement for Xbox is that we actually have to be able to handle like a lot of different motions and also very, very different agilities. You have to do it very fast, and also you have to do it for multiple people. But one thing that's different from traditional computer vision is that in addition to the RGB sensor, we actually do utilize this depth camera, which allow us to sort of do a depth map of the scene. So that's very, very powerful in terms of helping us understand the people's gesture. So the work that was actually used to create the gesture recognition algorithm is actually described in detail in this paper, which won the Best Paper Award at CVPR, which stands for Computer Vision and Pattern Recognition. So this was just published this year. And so the high-level view of the algorithm is that imagine you have this person in front of you. So you can imagine that what we do is we sort of draw almost like a bodysuit on top of this person. And in this bodysuit, you actually already have the 32 portions of your body already laid out. So what we're doing is actually, instead of trying to extract, where's the relationship between the different body parts, we actually turn it into a pixel by pixel identification problem. So imagine like any given body that's in front of the depth sensor, we actually are trying to draw at that point where the different pixels are in terms of the bodies, in terms of body parts. So you might say this is usually the right hand, left hand, or the head, and things like that. So we do that by building these models based on many images. So we do that using both real test data. So during this product, we actually went to many different people's like homes and so like find different lighting conditions, like different body sizes and different background scenes, and actually capture real data to allow us to evaluate essentially the accuracy of the system. And we also create synthetic data as well. So you can imagine that this is actually a very interesting and challenging problem because you have many images that you have to calculate. So we actually went to a Hollywood studio and went to one of these motion capture studios. So you can actually have different people doing different gestures in the studio, and then you can capture how they will look in front of that camera. And then after that, we also do state-of-the-art object recognition to actually identify the different body parts. So you can see that this is actually a big computation problem in the sense that you end up with billions of images. And how do you train up recognition system on all these billions of images? So we actually utilize parallel computing. So we use something called Dryad Link, which is a parallel computation platform that came out from Microsoft Research to be able to divide the task up into many different machines. And then from that, we can actually train up this machine learning system. So you can look at, so this is a graphical illustration of how the system works. You can see all these different body shapes that had the different body parts mapped already on the image. So you can see that this is a way for us to create this machine learning system that actually automatically adjusted to all the images. And in addition to recognizing body gestures, another innovation we did in Connect is actually putting in a microphone array and noise cancellation. So there's actually a very good talk on Mix that's available on this link here, which actually give you more detail essentially on how the microphone array work. So traditionally in speech recognition, one of the challenges is that you need to separate different people's speech, and also you have to cancel out the noise. So here are some examples I can show you on the before and after of the noise cancellation algorithm. No, it's not seeing this. I'm just playing the video. Yeah. So this is just I'll just do it again because the volume was a little bit low. So this is the audio that's captured. So imagine if you have to do speech recognition based on that signal. I mean, I'm sure most of you cannot tell what the user said. So this is the actual signal for the noise cancellation. So this is actually pretty impressive in the sense that we have actually taken a very sophisticated microphone array technology and put it into a consumer-priced device. So imagine if you have this on the Connect SDK, you can actually start doing speech recognition sort of in all kinds of different environments with different noise conditions. So traditionally, it actually has been pretty hard to actually hand build these microphone arrays, because usually you need to make sure that the arrays are lined up correctly and you have to calibrate it carefully. But now we actually have incorporated this into Connect so that you can utilize it for your own applications. So we announced that we're going to sort of release Connect SDK in spring this year. And then in June, we actually launched it, so it's actually now available online. So you can go and download the SDK. So how many of you have actually downloaded the SDK or play with it? Okay, so maybe 10% of the people. Okay, so it's actually very easy to use. So the SDK has a lot of different functionalities. One is it does have the raw sensor streams. So if you actually want to do your own research, for example, how to do gesture recognition, you can actually utilize the raw streams coming in from the depth camera and also from RGB camera, and sort of do your own evaluation or your own algorithm for doing that. And also for the microphone array, we have 4-element microphone array. You can actually take the raw signal from the 4-element microphone array as well. So if you are a computer science researcher and say you want to evaluate how the signal enhancement technology that I'm working on can be used, you can actually do that. And if you just want to utilize the SDK for applications, then you can actually utilize our sort of SDK's functionality to do the noise reduction and also to do the gesture recognition. So what you end up with is you have these essentially body gestures that you can recognize, and up to 2 people. So it's very easy essentially to essentially get the API to say where's the left hand, where's the right hand, and how far away is it from the camera. And we have also integrated the Windows speech recognition API, so you can actually just define a grammar, like for example, left, right, and then just do the recognition. It comes with a lot of simple code, so you have a documentation that allows you to actually download the sample code that people use to write up this simple scenario, for example, where we actually have a game that's based on Xbox Connect SDK. And then you can also utilize it for sort of prototyping different concepts. So right now it's designed for non-commercial purpose, but we will have a commercial version that's to come out later. So we also have a lot of sort of community involvement in this work, so that if you go to Channel 9, there's actually a lot of work that people have already done using Xbox SDK, so you can actually see the content. A lot of time, people are also sharing the source code, so you can actually go to Coplex and download a lot of project source code to see how people do it. And we also have events around the world, for example, in Seattle, UK, and France, and Australia, and New York, and then more are coming. So when we launched the SDK in June, we actually held this code camp in Seattle. So we had like 12 teams, like 36 campers essentially come, and they have 24 hours to develop scenarios based on the Connect SDK. So I'll just show you one example of what one team built using Connect in 24 hours. So this is called the conductor. So here's an example of what the person did.
Control the tempo using my beat pattern, just like a real orchestral conductor. So I can slow it down a little bit. Speed up a little bit. And I can also control the volume. So this is built using WPF with the new Connect to Windows SDK. And we started this just 24 hours ago. And
So this gives you a sense of what the SDK can be used for. So you can imagine that there are many creative use for the SDK that have actually come online. So I encourage you to go and take a look. So that's one example about using Connect for doing new application scenarios. So as I mentioned, a lot of Connect is based on a lot of machine learning in the back end, essentially to do this sort of gesture recognition and also speech recognition. So next I'm going to introduce a library that has been provided for Microsoft Research to actually allow you to do some data manipulation and data analysis. So the project's name is called Show. So what is Show? So there are tons of data around, like collected around the web and also around sensors that you can have. So you can imagine that if you have this case like a matrix of random numbers, 5x5 matrix, what you want to be able to do is actually very quickly do some analysis. So in this case, it show a quick plot of one of the arrays in the matrix. So the data can come from either SQL Server, or it could come from web pages, or it could also come from web services. It could also be just so comma separated files, and also it could be like from different libraries and log files, and then documents. So there are a lot of different type of data, and this show has been actually used for doing text analysis and numerical analysis, and also could come from the cloud. So what we want to do is actually allow people to easily do math manipulation and then also do data visualization using plots, and you can also have a .NET integration and also rapid prototyping. And then what we want people to be able to do is actually extract insights from all that data easily. So what it does is actually does provide a set of libraries that you can actually do manipulation on the data. So you can see that we have a lot of different capabilities, such as matrix manipulation and also common decompositions. And then if you go to this web page, you actually find there's actually a nice tutorial essentially on the use of Show. And it also allows you to do visualization. So you can actually very easily, like for example, if you take this center plot here, area versus population, so you can actually very easily plot something like that out of data. So imagine if you had a .NET-based system where you can actually easily pull population distribution across the US, and then look at, for example, the sales number across the population. You want to correlate that with the population density, then you can easily do that by using this, this library. And it has features, for example, so you allow on the console, it actually has sort of like IntelliSense to allow you to sort of easily use all the different functions, and then a lot of documentation as well. And you can also generate documentation on your work. So I know how many of you have actually used MATLAB? Have people used MATLAB? So this might seem very familiar to people who have used MATLAB, and also R, which is another package that people use for statistical analysis. So, so what we want Show to be able to do is allow people to utilize essentially a data stack from Microsoft using .NET libraries and then language and IDE and so Excel and SharePoint to actually extract and compute on all that data. So this allows people to prototype and play with the data very, very easily. And we believe that this is actually becoming more and more important part of people's toolbox, in the sense that as a developer, now you actually have to analyze a lot of data on the fly, and this will allow you to do that. So it's based on .NET, and then we use Python, and then it has a console mode, and also it has CLS libraries that allow you to actually look at the packages. And the third thing I want to talk about today is called Infer.net for machine learning. So this is another set of utilities that come from Microsoft Research in Cambridge. So it's actually used to do a probabilistic reasoning. So probabilistic reasoning can be used in many, many domains. Like for example, in social network, right? You can imagine getting input if you use Facebook data and things like that, and see people's likes and things like that. So you have a lot of input variables that you can use. And can you infer, for example, what's the musical taste of the user? And you can recommend more songs. So that's a very typical type of things where you do collaborative filtering. So what you use is a lot of features. Another example is Netflix, for example. Netflix actually had a challenge on machine learning where they have a lot of variables on different people's many people's input, essentially, on which games and which movies they liked. And you can actually use this to do machine learning. Or also in healthcare, we actually have done work in doing sort of inference on patient status. So one practical example that I can give you is, so you know that for a patient who's being discharged from the hospital, it's very expensive for the patient to come back like within the next 1 month, in the sense that ideally you want to be able to give the patient enough instructions and support so that they sort of recover well in their family and in their home. So there are things that you can do. For example, you can call up the patient and say, remind them to take their medicine at regular hours and make sure that they are aware of the current status of their treatment plan. But it's also very expensive to do that. Imagine you have to do that every time for each patient discharge. So what we have done the work along with the hospital is we actually build this machine learning model that actually look at the previous history, and then you are trying to look at the sort of data of the discharged patient, for example, the type of the conditions they had, the treatment plan, their age, etc. And then you try to predict, what's the percentage of people who are most likely to have a recurrence, like basically return to the hospital. So by building this model, we can actually track and sort of like predict what's the likelihood some patient is actually going to be coming back to the hospital. So we focus on the group of patients who are most likely to come back to the hospital, and then so we give them additional instructions. And for example, the hospital can call them up in 3 days and in 7 days interval to remind them to continue to take their pills and then to follow the treatment plan. So by doing this, you can actually still have a very effective delivery of healthcare, but without essentially utilizing all the resources that you need. So Info.net has been used for many different applications. So you can use for program verification, recommendation, and it has been used for genetic research, and then you can also use it for population modeling. So I'll give you a concrete example of how this can be used. So imagine the simplest case to do probabilities, like flipping coins, right? So if you toss 2 fair coins, what's the probability that both are heads, right? So what's the probability that both are heads if you toss the 2 fair coins? A quarter, right? So traditionally, you can do this by doing mathematical simulation. So imagine like you have like 2 coins, right? And then both are like 50%. So you can actually just sort of enumerate all the different options. So you can imagine like playing this scenario many times and then do a cumulative sum. And then after that, sort of determine the percentage of the final outcome of 2 heads. But it's actually a very expensive process. You can do that, but it's actually going to be very time consuming. Especially imagine the cases we're talking about. Let's say for Netflix, they have maybe input feature of over 1,000. Then it actually becomes very expensive to actually do this simulation, where you actually have to simulate one by one, the different alternatives. And imagine that you have sort of like 1,000 variables, and then to actually run the simulation based on that, it will not be practical to do it in any given amount of time. So with Info.net, what we allow you to do is actually do this in a probabilistic inference model. So the example here would be, if you take a look at this case, so you can define essentially the first coin to be a Bernoulli process with a 50% probability, and the second coin to be another Bernoulli process with 50% probability. And then you run the inference engine, and you basically just infer both heads, essentially by saying first coin is true, and then second coin is also true. So you can imagine that instead of running this simulation multiple times, you just run this inference using Info.net, and then you actually come out with a result, like 25%. So this is one example where you utilize Info.net to pull this kind of information out from your simulation. So this is actually available online. So if you look at this webpage below, you actually find many other sort of examples of how Info.net has been used in many different domains. And then there's also a lot of documentation online where you can actually find ways of utilizing the library. So one of the things that people tell you that the biggest challenge in giving talks is between the audience and the food. So today, one of my goals is actually to be short, so that make sure that you are in time for food in plenty of time. So you actually see like very quick examples of how Microsoft Research has actually done research over the years, and then we actually do want to provide a lot of these capabilities to the community because we would like to hear feedback. So there are examples. For example, how many of you have heard of F#? Oh, great. Okay, so F# is a functional programming language. So that came out of Microsoft Research in Cambridge. So it was originally put out in a sort of more of an exploratory beta form on a research website. But now it actually offers a lot of community feedback. It actually has been incorporated as part of Microsoft Visual Studio product line. So that's one example where we would like to put these resources out there online and allow people to play with it and give us feedback. And then we really enjoy sort of having feedback from the community to let us know how the work sort of helps them in their daily jobs. And I would also like to acknowledge the following people: Stuart Hensley and Jamie Shohan and Sumi Basu and John Wynn, who provided the content. And there are actually a lot more content on Microsoft Research website. So if you want to look at the specifics of the libraries I described today, so they are online here. So Connect SDK is for Connect on Windows. And it's actually, we just released the sort of .1 version, so we just provide an update to that. Show is actually available online as well, so you can download and play with it. And then infer.net is also available. So I encourage you to go and explore. And there are actually a lot of other libraries that are available on research.microsoft.com's website as well. So that will be very easy. And then there are resources online from Microsoft. And please provide your feedback on the session. And then, so lastly, so I'll be here after the session. So if you have any questions, I'll be happy to answer them. And thank you very much for your time, and enjoy your lunch. Thank you.